Betelgeuse or Betelgeuse is a red giant star. If you put it where the Sun is, it would extend out to the orbit of Jupiter, enormous, very unstable, and about to explode. These types of stars are among the biggest sources of radio energy in the entire universe, generating more energy than 1 billion suns. When we think of stars, we probably imagine tiny shiny objects in the night sky. At least this is how we see them from down here on Earth. However, stars are something else entirely. In fact, one of the biggest stars, Betelgeuse, happens to be much larger than our Sun. For years this star has baffled scientists, but recently something more unsettling has been happening with Betelgeuse, making scientists and other well-informed individuals very concerned. Join us in this discussion as we explore the significant news about Betelgeuse, its impending destruction as expected by the James Webb Space Telescope, JWST, and how this new development will affect our galaxy and our lives here on Earth. The nature of Betelgeuse. As explained by physicist Michio Kaku, Betelgeuse is a cosmic wonder, a massive star that has intrigued cosmologists for a long time. A Greek astronomer named Ptolemy was the first to discover it. This star is so large that it can be seen in the night sky from Earth, particularly during winter. If you're interested in constellations, you've probably seen or heard of Betelgeuse. It is the reddish-orange star that marks the upper left shoulder of the Orion constellation. This star is ancient and one of the brightest stars in the night sky. However, one thing about Betelgeuse's brightness is that it does not stay constant. Instead, it fluctuates. This fluctuation is one of the unique properties of the star, but it isn't the only one. The immense size and distance of Betelgeuse. Most of the stars you see in the night sky are actually very far from Earth. The nearest star, Proxima Centauri, is 4.2 light-years away. To put that into perspective, 1 light-year is the distance that light can travel in a year, which is about 5.88 trillion miles, 9.46 trillion kilometers. That means Proxima Centauri is billions of miles away from Earth. However, some stars are even farther away, and Betelgeuse is one of them. Betelgeuse is located approximately 600 light-years away. If you were to travel to it at the speed of light, it would still take 600 years to get there. Our current spacecraft are not nearly fast enough to reach it within a human lifetime. Betelgeuse's brightness and size. Despite its distance, Betelgeuse shines brightly in our sky because of its immense size and luminosity. The star is about 500 times larger than the Sun, and its radius is nearly 1,000 times that of the Sun. If placed in our solar system, Betelgeuse would engulf the orbits of Mercury, Venus, Earth, Mars, and even Jupiter. In terms of mass, Betelgeuse is estimated to be between 12 and 19 solar masses, where 1 solar mass equals 210 superscript 3 kg. Since there are no planetary bodies orbiting Betelgeuse to use for mass comparison, scientists cannot determine its exact mass. However, they have confirmed that it is at least 12 times heavier than our Sun. The brightness of Betelgeuse fluctuates, ranging from magnitude 0 to 1.6. To put this in perspective, Betelgeuse is 16,000 times brighter than our Sun. No wonder it is classified as a red supergiant. Why does Betelgeuse's brightness change? Betelgeuse's brightness does not remain constant because the star expands and contracts in cycles. When it expands, it becomes brighter. When it contracts, it dims. These pulsations can last anywhere from 10 to 100 days or more. Another interesting feature of Betelgeuse is that its surface is covered in dark magnetic spots. These spots are significantly larger than those on the Sun, sometimes twice the size of Earth. The magnetic field in these regions is much stronger than in other parts of the star, hindering the flow of hot gas to the surface, making these spots cooler. Betelgeuse also has a magnetic field that is 1,000 times stronger than that of the Sun. This intense magnetic field causes gases on the surface to appear in loops or arcs when viewed through telescopes. The cooling of Betelgeuse. Betelgeuse's surface temperature is approximately 3,500 K, which is significantly lower than the Sun's 5,778 K. This lower temperature gives the star its red-orange hue. Interestingly, Betelgeuse wasn't always red. 2 million years ago, it was yellowish, similar to our Sun. About 2,000 years ago, it began turning red, leading scientists to believe it is nearing the final stages of its life cycle. Betelgeuse's dimming events. In late 2019 and early 2020, Betelgeuse experienced an unprecedented dimming event where its brightness dropped by nearly 60. This led many to speculate that the star was about to go supernova, a dramatic explosive end to a massive star's life. However, subsequent observations suggested that this dimming was caused by a combination of factors, including the ejection of material from its surface and the formation of a dust cloud that temporarily obscured its light. When will Betelgeuse go supernova? Betelgeuse is expected to explode as a supernova sometime within the next 100,000 years, which in cosmic terms is relatively soon. When it does, the explosion will be so bright that it will be visible from Earth during the daytime. The supernova will release an enormous amount of energy, enriching the interstellar medium with heavy elements that could contribute to the formation of new stars and planets. Despite this imminent explosion, Betelgeuse is far enough away that when it goes supernova, it will not pose any direct threat to Earth. However, its explosion will be one of the most spectacular astronomical events in human history. The role of the James Webb Space Telescope. The James Webb Space Telescope, JWST, is actively observing Betelgeuse to understand its behavior better. The telescope's advanced infrared capabilities allow astronomers to penetrate the dust clouds around the star, providing clearer insights into its structure, temperature, and composition. Conclusion: Betelgeuse is a fascinating cosmic giant that continues to intrigue astronomers and skywatchers alike. Its enormous size, fluctuating brightness, and impending supernova make it one of the most studied stars in the universe. When Betelgeuse finally explodes, it will leave behind a neutron star or a black hole, contributing to the ongoing cycle of stellar evolution in our galaxy. Betelgeuse's imminent supernova. Betelgeuse is nearing the end of its life cycle, and when it finally explodes in a type supernova, it will be one of the most spectacular events visible from Earth. When will it explode? Astronomers estimate Betelgeuse could explode within the next 100,000 years. However, there is no precise way to predict the exact timing. The star's dimming event in 2019-2021 led some to believe the explosion was imminent, but further research attributed this to a dust cloud expelled by the star. How will it look from Earth? When Betelgeuse goes supernova, it will be as bright as the full moon and possibly visible even during the daytime for weeks or months. It will not pose any harm to Earth because it is about 600 light-years away, well beyond the 50 light-year danger zone where gamma-ray bursts could affect our planet. What happens after the supernova? Depending on its final mass, Betelgeuse will either become a neutron star or a black hole. The explosion will release heavy elements like iron, gold, and uranium, enriching the interstellar medium and possibly leading to the formation of new stars and planets. Observations and future research. The James Webb Space Telescope, JWST, is currently studying Betelgeuse in infrared wavelengths, allowing astronomers to analyze its surface activity, mass loss, and internal structure. The Hubble Space Telescope and other ground-based observatories continue to monitor fluctuations in brightness and mass ejections. Future telescopes, such as the Extremely Large Telescope, ELT, will provide even more precise observations of Betelgeuse and other supergiants. Impact on astronomy and science. Betelgeuse is a unique opportunity for scientists to study a supernova precursor in real time. If it explodes within our lifetime, it will help refine models of stellar evolution, supernova mechanics, and cosmic element formation.